In section 1.2, we'll talk about linearity, is something a line or not, and talk about intercepts, what they might mean in a situation. We won't actually hit too much with symmetry right now. If it's something we want to discuss, we can get into that a little bit later. Not as crucial right this second. So linear function, we might be talking about that function notation. It's basically no variables raised to a power other than one. So we're talking about x to the first power. That would make something a linear function. We can talk about just a linear equation, sorry, a little typo there. A linear equation can represent a linear function if it could be written in this form. So we can see different formats. Ax plus by equals c, something we might call standard form. Y equals mx plus b, or fx equals mx plus b. You've seen that before as well. Nonlinear just means it's not a straight line. We can't put it in this format. We got x other powers, all that good stuff. The most common example you've seen before is a parabola, is when you get a quadratic, y equals x squared, you get something that's more of a curve. So, can we determine whether these are just by looking at the equation? We could try to graph it and see what the graph looks like, but maybe just from the equation we can figure it out. And I know this one doesn't quite look like our other formats here, but could we simplify it? Could we arrange it some way? We got f of x or y, and if you notice, you could just divide by 3, 6 divided by 3 would be at 2x, and 5 divided by 3 doesn't really work that well. It could be a decimal, or we could leave it as 5/3, but what you do have here is that, linear function format. We got that good old y equals mx plus b format. Maybe not the most, maybe the easiest point to plot, but we can still work with that. So this one would be linear. This one, pretty much right away you can tell it's not. We have x to the third power. If you really want to go to the effort of getting y by itself and dividing by 5, you could rearrange it, get a bunch of fractions. But really already you can tell x is to the third power. That is not a linear function, so we'd say this is nonlinear. Gets even easier when you actually see the graph. Clearly this one here is a straight line. We hit all those points that they're indicating there, so one straight line, so this one's definitely linear. This guy, some people say oh, it is linear because there's lines. Well, there's two separate lines, like point A, B, and C. I can't hit them all with one line, so this would be non-linear. Even though it has straight, like line parts, it's not linear, one straight line. Okay? You might be given a table, and I thought the textbook was kind of funny because they're like, you could just plot these points and see what the graph looks like. And yeah, you could do that on paper or use Desmos and plot the points, but that takes a lot of time. Probably faster just to kind of look at the tables. There's some changes we could look at. Because to be linear, you should see a consistent add or subtract pattern. You can see your weeks here, your x's keep going up by 1. If you explore these changes, to go from 85 to 119 is a change of adding 34. And if you keep doing that, it keeps adding 34 each time, nice and consistent like that. They keep adding the same thing. Essentially, your slope is 34 over 1, since these are changing by 1. Okay, so that would definitely be a linear function. Other thing we want to talk about is intercepts. Again, you've seen this before, so it's not too crazy. Your x-intercept is just where the graph crosses the x-axis. You would write it as x comma 0. So it'd be 3 comma 0 or -5 comma 0. Your y-intercept is where the graph crosses the y-axis. So we'd say 0 comma something. We don't move left or right. We say it's 0, but we move up or down to something like 0, 3 or 0, -7. Cool. So let's just find some intercepts. So on this graph right here, we just look to see where it crosses. This one's unique because actually your x and y intercept are both 0, 0. So both of these guys would be 0, 0. It crosses the x-axis at 0 and the y-axis at 0. So there you go. We can also look at more complicated looking graphs, and later on in other chapters, we'll actually find these algebraically, find mathematically how to get those answers. Right now we're just kind of estimating where they appear to be, looking at the graph. This one seems to be at an x-intercept of -3, 0. We've got another one at -1, and then there's even a third one at 2, 0. So there's actually 3 x-intercepts. And in most typical functions that we come across, there'll only be one y-intercept. This one appears to be at 0, 12 if you watch your scale and count appropriately. It looks like they're counting by 4s, so I'd estimate that that's around 0, 12. You can pause and even try this yourself. Pretty straightforward stuff. X-intercept here would be -5, 0, and your y-intercept would be 0, 2. This one's got a whole bunch of x-intercepts, so just take the time, find them all. There should be one at -4, at -2, at 0, at 3, at 5. So lots of x-intercepts. But only one y-intercept right there at 0, 0. All right. We can also have a table, a real-world situation, and we're trying to interpret the meaning of these intercepts. What do they mean? Okay. You could actually try to graph this, although the points are quite large and all that. You would have something like this, especially a rocket being launched would fly off and then come back down and hit the ground. So really all we're looking for though is some zeros. X and Y intercepts have to do with zeros. So 0, 15 would be your Y intercept. Okay, because we're at 0, 15. And what that really represents is 0 seconds. So at the start, 0 seconds would be right at the start. The rocket starts 15 feet in the air. So it's on that balcony, right? They said 15 feet in the air would be the starting point here. Your x-intercept, look for the other 0. Right here is 0. So it's at 8 seconds. So 8 comma 0 means the time. After 8 seconds, that rocket would hit the ground. Right here would be 8, 0. So it has a height of 0, so it's hit the ground. All right, that was the end of that section. So bring questions to class.